Hey, welcome to another video by Mr. Nelson. This time we're doing molar mass, practice sheet number 4, question number 5, and we are doing moles to mass. So we're going to convert the number of moles of a compound, in this case, to how many grams that actually is. So it's basically just a conversion factor. So our conversion factor is using molar mass. So remember, 1 mole will equal the molar mass of the compound that we have. So let's go ahead and read the compound, or the question, and it says how many grams are there in 3.30 moles of dinitrogen hexaiodide? Okay, so first thing we need to do is figure out how many significant figures we need in our answer. So if we look at these three right here, again, numbers are always significant. So zeros are the ones that we're going to worry about. And the rule for this is it's trailing and there's a decimal. It has to have both of them. It means the zero is significant. So the number that we're going to put right in there is going to be 3. So we have 3 significant figures. So our answer needs to be in 3 significant figures. So let's go ahead and figure out what is the formula, because we have to have the formula of this compound in order to determine the molar mass. So right away I look at it and I see di and hexa. So we have to write in whatever the prefix is the subscript for that particular element. And again, the reason we know that is because when we do nomenclature for type 3, prefixes mean that's how many of that particular element we have. So I'm going to know right away that we have nitrogen and we have iodine. Now, I'm going to do one thing really different with this right here, as I kind of always do. I want to make it so we see it. So let's see if iodine is going to be right there. So I have di. Di means what? Well, di means 2. Okay. Hexa. Now, off the top of my head, I might not know what hexa means. So we're going to go to our packet. So if I go to our packet and we scroll down to the rule nomenclature rules, which is going to be right after the monoatomic sheet. So it should be on page 15. There's 14. Should be the next page. Even though it says 12, it's 14. Let's go to type, and while you're on the next one, type 3. That's on that next page. So type 3 right here, our prefixes are going to be that. So we go down to hexa, and I see hexa is 6. So we have 6 of those. So if I go back to our problem, hexaiodide, so we're just going to put in a subscript of a 6. So there is our answer right there. So now we have our formula. Once we go from our formula, now we can go to our molar mass of that particular compound. So what do we need to do? We need to come back over here, and we're going to put in nitrogen, and we have 2 nitrogens, and then we're going to do iodine. Iodine, we have 6 iodines, and I know what nitrogen is. The atomic weight of nitrogen is 14. I don't know what it is for iodine. I think it might be 137, but let's go ahead and check, because we always want to double check, not just go on mine, because I know me, I can't remember a lot of different stuff. So we'll go back up and see what it is on our periodic table. So let's find iodine. Oh, I said 137. It's actually 127. See, so good thing we double checked. So let's go back and put in 127 right there. Okay. And so now what we're going to do is we're going to put that, make that equal. So what does that equal? Well, 2 times 14. Oh, that's a tough one. It should be 28. But do you know what 6 times 127 is? Well, I don't. So we're going to go back over here. 6 times 127 equals 762. Ooh, 762. Well, let's double check that. It kind of makes sense because 6 times 100 is 600. Okay, so we're going to clear that off again, and we're going to do it again. So 6 times 127 equals. There we go. That's correct. So we're going to figure out the molar mass, and that's going to equal. Okay, so the molar mass is going to equal those added up together. So when I add those together, we're going to go back over here, and we're going to do 28 plus 762 equals 790. Let's do that again. 28 plus 762 equals 790. So we're going to put in here 790, and that's going to be grams of what? Of dinitrogen hexaiodide. So we're just going to go ahead and copy that. So we're going to copy, and we're going to add that right there, paste it. Okay, so now we know what the molar mass of that is, and that's how much 1 mole weighs. So just 1 mole weighs 790 grams of dinitrogen hexaiodide. So if I have 3.3 moles of dinitrogen hexaiodide, how much does it weigh? So we're going to always start off with what we have in the original problem. So 3.30 moles of, and we're going to put the dihexaiodide in there. Then we always put our times in our line. Oops, hit the wrong one. And let's just go times in a line. And we're going to put moles on bottom. Well, how many moles did I say this is equal to? Okay, it's equal to 1 mole. So we're going to put in here 1 mole of dinitrogen hexaiodide. Okay, and that equals this right here. So we're going to take this right here, copy this. Okay, copy it, and we're just going to paste it right here. And paste. Okay, we're going to move that over, and then we're just going to go ahead and underline that. So once we get that underlined, we're going to go ahead and we can do the math. But remember, before we do the math, we have to eliminate anything that we can eliminate. So in this case, we can come over here and we can eliminate this and this because they're over top of each other. And again, remember, if anything's over top of each other, we can get rid of it. So we're going to go ahead and go back up to our format, and we're going to strike through that. So that's eliminating that, but I have to eliminate both of them. Can't just do one, because if anything is left there, then those units have to be put in the answer, and it would be wrong. It'd be wrong if we didn't get rid of it either. So now all we have to do is go ahead and take our numbers, which is, that's all that's left is numbers here and this unit. So we're going to come back up to our answer up here. We're going to take 3.30. We're going to multiply that by 790. And then we're going to divide by 1. I don't have to divide by 1. I think all of us know that by this time. Hit enter, and I'm going to have 2,607. Ooh, that's a good number, 2,607. And that's going to be, we're going to paste this in there, and I'm going to get rid of this part right here. Boom, doop. So now we know what we have here. So we have 2,607 grams of dinitrogen hexaiodide. But that's not a final answer because we're not in the correct number of significant figures. So we need it in 3 significant figures. We'll put our line right here. So I need to get rid of this one right here. So that means I need to, the 7 says I need to round up. So I'm going to get rid of the 7. I need to keep the place though. So I'm going to put a 0 there. And that 7 rounded up to 1. So I have 2,610 grams. Now, if I really look at what I had before, and I'm going to put that in there, I'm going to put it right here. I had 2,607. So this right here rounded up to 10. And so there's 10, but I had to have the 0 in there. Now that's 0 right there, and I'm going to go back and get rid of this. This 0 here is not significant. And why is it not significant? It's trailing. So why isn't it significant? Well, if you look at the rules, it says it has to be trailing and there has to be a decimal in the number. In this case, there's no decimal in the number, so it's not significant. So there's our answer. Go ahead and highlight it. And then we're done. So 3.3 moles of dinitrogen hexaiodide weighs 2,610 grams. Hey, as always, go Mohawks. Nelson out.